Welcome to the DIY Honda Garage channel. DTC P1659 indicates a malfunction with the Electronic Throttle Control System, ETCS relay. This error highlights a problem that could potentially impact the vehicle's throttle response and overall engine performance. The malfunction typically stems from issues within the ETCS control relay or the associated circuitry. The ETCS relay is located within the under-dash fuse relay box, which is situated on the driver's side of the vehicle, close to the steering column. The relay is responsible for managing the power supply to the throttle actuator, thus directly influencing how the vehicle accelerates. When diagnosing this DTC, it's crucial to consider both electrical connections and the relay's functionality to ensure proper operation of the throttle system. The error description related to DTC P1659 indicates an Electronic Throttle Control System, ETCS relay issue. This relay plays a pivotal role in regulating the power delivered to the throttle actuator, ensuring proper throttle response during driving. Located in the under-dash fuse box, the relay must be functional for the electronic throttle system to operate correctly. If the ETCS relay experiences failure, it can disrupt signal paths and power delivery, causing unwanted throttle behavior. Malfunctions in this relay result in the system not receiving the appropriate signals and power, ultimately leading to the DTC being triggered. Addressing this issue involves evaluating both the relay and associated wiring paths. Several potential causes may lead to DTC P1659 being displayed. A primary suspect is a faulty Electronic Throttle Control System, ETCS relay, which could simply be failing to operate correctly. Additionally, a blown A22 fuse, which is a 15-amp fuse located in the underhood fuse relay box, could also be culprit. If this fuse is blown, it will interrupt the power supply needed for the relay function. Wiring issues may also be at play, which include open circuits or shorts in the connections between the ETCS relay, the powertrain control module, PCM, or the throttle body. Each of these potential causes can interrupt the circuit necessary for proper throttle operation. To effectively resolve the malfunction, thorough examination and testing of these components are essential. Symptoms associated with DTC P1659 typically include poor engine throttle response, which could manifest as hesitations during acceleration or a lack of responsiveness to accelerator input. The check engine light will likely illuminate on the dashboard, indicating an issue that warrants attention. Drivers may also experience intermittent performance issues, where the vehicle sometimes behaves normally and other times does not, leading to unpredictability in driving conditions. These symptoms can create safety concerns and lead to suboptimal driving experiences. If the vehicle exhibits these symptoms, it reinforces the need to initiate repair protocols to identify and rectify the underlying issues promptly, especially to maintain vehicle safety and drivability. The first troubleshooting step involves turning the ignition switch to the on position, which powers up the vehicle's electrical systems but does not start the engine. Following this, it is essential to utilize the Honda Diagnostic System, HDS, to clear any existing DTCs from the vehicle's memory. This step is crucial because it allows for fresh data collection, ensuring any new issues can be accurately reflected. After clearing the DTCs, it is necessary to check for any pending or confirmed DTCs. If DTC P1659 is indicated, it confirms the presence of the fault in the system, and you would proceed to the next step in the troubleshooting process. However, if the code is not present, it may suggest an intermittent issue, leading to additional checks of the connections at both the ETCS control relay and the PCM. In the second troubleshooting step, turn the ignition switch to the lock 0 position to safely power down the vehicle's electronic systems. Next, check fuse number A22, a 15-amp fuse located in the under-hood fuse relay box. This fuse is pivotal as it directly supplies power to various components, including the ETCS relay circuitry. Ensuring this fuse is intact is crucial, as a blown fuse can lead to an absence of voltage that will prevent the relay from functioning correctly. If the fuse is confirmed to be okay, the troubleshooting can progress to testing the ETCS control relay in the next step. If the fuse is blown, addressing this fault would be the immediate priority before investigating further. For the third step in troubleshooting, the ETCS control relay must be removed from the under-dash fuse relay box for further assessment. With the relay detached, perform a functional test to determine whether the relay is operational. The testing process typically involves applying voltage to the relay terminals and checking if the circuit is completed correctly, which is vital for its functionality. If the ETCS relay is confirmed to be functioning properly, this indicates that the issue may lie elsewhere, requiring further investigation into subsequent components. However, if testing reveals that the relay is faulty, replacing the ETCS control relay should be the next step, followed by repair verification to ensure that the DTC has been effectively resolved. The fourth troubleshooting step requires turning the ignition switch to the on-to position. In this condition, it is critical to measure voltage between designated test points in the circuit. The test points involve the ETCS control relay 4P socket number 3 and body ground. This measurement will help ascertain whether battery voltage is indeed present at the appropriate location when the relay is disconnected. If battery voltage is detected, it confirms that voltage is reaching the relay properly, indicating that the circuit leading to the relay is functional. Conversely, if no voltage is detected, this suggests that a fault may exist in the under-dash fuse/relay box, necessitating its replacement to rectify the issue. In the fifth troubleshooting step, we focus on measuring voltage on the +B ETCS line by again turning the ignition switch to the on-I position. The objective here is to assess voltage between the ETCS control relay 4P socket number 1 and body ground. This test is crucial for confirming that battery voltage is present on the +B ETCS side of the circuit when the ETCS control relay is disconnected. A positive reading indicates that the circuit supplying the relay is intact. If the measurement reveals no voltage, further investigation into the wiring and connections is necessary. As the +B ETCS line is essential for powering the relay, addressing faults in this routing must be prioritized before exploring additional steps. The sixth troubleshooting step requires turning the ignition switch to lock 0. Disconnect the under-dash fuse relay box connector D32P to access and evaluate the +B ETCS line properly. By measuring the voltage between the specified test points while the circuit is disengaged, technicians can ascertain whether the +B ETCS wire is intact. Test point 1 involves checking the LT green wire within the connector, and if battery voltage is present, it indicates the wire is functioning correctly and can proceed to replace the under-dash fuse relay box. However, if no voltage is detected, repairs to the open wire will be essential between the A22 fuse and the under-dash fuse relay box to restore continuity. In Step 7, the focus shifts to checking for continuity in the VB-ETCS or ETCS RLY outline. This starts with the ignition switch turned to lock 0 and requires the SCS line to be jumped using the HDS for diagnostics. Disconnect the PCM connector C49P next, allowing for continuity testing between the specified test points while isolating the ETCS control relay. If no continuity is detected, it suggests that there is an open in the VB-ETCS ETCS RLY outwire within the circuit. This issue should be addressed by repairing the open wire located between the PCM and the ETCS control relay, allowing for proper electrical pathways to enable functionality. The 8th step in the troubleshooting process involves assessing the ETCS RLY-CL line for continuity. Begin by disconnecting the PCM connector A, 49P, while keeping the ETCS control relay disconnected. At this point, continuity should be checked between the test points indicated: PCM connector A, number 48, PUR, and the ETCS control relay 4P socket number 4. A successful continuity test indicates that the wire is intact. However, if continuity fails, repairs will be necessary to resolve the issue between the PCM and the ETCS control relay. It is also advisable to check the PCM to ensure it has the latest software updates to prevent programming-related faults in the future. In the 9th step, the focus is on identifying any shorted wires present in the VBET-CS ETCS RLY outline. To do this, ensure the ETCS control relay is removed from the underhood fuse relay box and proceed to jump the SCS line using the HDS. Disconnect the PCM connector C, 49P, and check for continuity between the designated test points. A successful test indicates the presence of a short. If the wire is intact, proceed without repairs in this area. Identifying a short is critical for ensuring proper electrical functionalities within the throttle control system, as shorts can lead to erratic performance and further issues. Step 10 involves determining connectivity in the +B ETCS line, which can significantly affect throttle control functionalities. Start by checking the continuity between test points involving the ETCS control relay 4P socket number 1 and body ground. Maintaining the ignition in the lock 0 position while ensuring the ETCS control relay is disconnected is essential for accurate measurements. If continuity is confirmed, it indicates proper connectivity, and the troubleshooting can advance to the following step. Conversely, if continuity is absent, the next action should involve ensuring that the PCM has the latest software version. If not, updating or substituting a known good PCM will be necessary. The 11th troubleshooting step is focused on assessing whether there's any shorted wire within the +B ETCS line. This involves disconnecting the under-dash fuse relay box connector D32P and checking for continuity between the indicated test points within the circuit. If continuity is confirmed, it would confirm the integrity of the wiring, allowing for repairs of any shorts detected in the wire path. Conversely, if there's no continuity, the next step would involve addressing the wire between the A22 fuse and the under-dash fuse relay box. Completing these checks ensures that all aspects of the circuit are functional and contribute to the overall performance of the throttle control system. Final repair verification is an essential step to ensure successful resolution of DTC P1659. Begin by turning the ignition switch to the lock 0 position, followed by reconnecting all previously disconnected connectors, including those on the ETCS control relay and the PCM. Once all connections are restored, turn the ignition switch to the on 2 position. The next step involves resetting the PCM using the Honda Diagnostic System, HDS, which clears any stored DTCs from the system and prepares it for relearning engine parameters. After resetting the PCM, it's vital to perform the idle learn procedure to ensure optimal throttle response. Finally, check for any pending or confirmed DTCs again to confirm that the repair has resolved the issue completely. Preventive maintenance plays a critical role in minimizing the chances of encountering DTC P1659 in the future. Regular inspections of the ETCS control relay and its connections should be conducted to ensure that no corrosion or wear compromises functionality. Additionally, ensuring that the A22 fuse is regularly checked for integrity can prevent potential disruptions in the power supply to key components. Keeping the PCM updated with the latest software will also help mitigate programming or communication issues that could arise, impacting the throttle system's performance. Implementing these preventive checks can significantly enhance the reliability of the vehicle's throttle control system and prolong its lifespan. In summary, troubleshooting DTC P1659 requires a systematic approach, focusing on identifying relay and wiring issues that may compromise the Electronic Throttle Control System, ETCS. The steps involve verifying voltage levels, checking fuses, and inspecting the ETCS control relay's functionality thoroughly. Proper diagnosis and correction of any issues found can restore the system's reliability and ensure optimal vehicle performance. Additionally, implementing regular maintenance practices can prevent future occurrences of this DTC, safeguarding the vehicle's operational integrity. Taking these measures not only assists in resolving immediate concerns, but also promotes the long-term health and performance of the throttle control system. Please like and subscribe to the channel. See you next time.